welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. This is the show that's unique. We go deep, we go all the way down. We are unapologetically technical about it, and this is how we like to do things. My guest today is Hubert Dulay. He's a developer advocate at StarTree. Welcome to the show, Hubert. Would you mind introducing yourself a bit more?
Yeah, thanks for having me, Jesse. Really happy to be here. I'm Hubert. I am a developer advocate at StarTree. My background is over 20 years of engineering, mostly in data, the latter half mostly in big data and fast data. I worked at Confluent, Cloudera, and currently at StarTree, who's the commercial entity behind Apache Pinot.
Excellent. Well, I think we're in for some good discussion then. So, you talked about quite a list of companies and fast data and real time data. What makes you so interested in this subject?
Um, well, I've been in data for a really long time. I've When I first started as an engineer over 20 years ago, I knew really quickly that I was not a front end developer. I was just really terrible at that. I was just doing things in the back end. And typically, when you're working in the back end of an application, there's a lot of data, and there's integration and sharing that data and preparing that data so that it's used somewhere else. So that's where I've been for the majority of my career.
Well, good. And you've written two books, and I've written three or so books. Birthing a book, and I use that word literally, it's a significant amount of work. It's a huge amount of work just to write one book. You've written two books. What makes you so, I guess, energized enough to write two books?
Um, See, the two books that I've written all are about streaming. So they're like streaming whatever, right? Like the first one was streaming data mesh. This one, the next one is streaming databases. I'm sure if I were to write one immediately, that have streaming prefix to it, undecided. But I think that's by accident. I think the streaming and fast data world is a bit of a new frontier. There's lots of things to talk about. People are trying to solve problems in real time, and not everyone is really used to or even know that they need that sort of thing. So there's a lot of education that needs to be happening, and I think there are some books lacking. So I start writing these books as a out of a necessity, just to kind of organize my thoughts, just to test the waters for the market of some of these technologies I'm talking about. And then, yeah, I have a lot of ideas that if I can compile them into something like a book, or I can organize it into a book, then I'll put a proposal to O'Reilly to see if it sticks.
That's interesting. This is kind of like a way for you to test an idea or test the effectiveness of an idea, then?
Right, right. So the book typically is only about 60% done in my head before I decide to write the book. There's a lot of research that goes along with it, as because I'm learning it myself. When I was writing this last book, streaming databases, I I tried to kind of record some of my research. So I did some podcasts, interviewed some founders and technical people that are associated with that. In this case, streaming databases, and kind of understood where and why they were doing things in such a way. So all that's recorded. I enjoyed that process. It was a lesson that I learned after I wrote the first book, Streaming Data Mesh, where I think not exposing all of that um, uh, wouldn't help. Number one, market the book, but also help understand where all the information actually came from. You could do a lot. You could reference a lot of books and text, but when you're interviewing and you're And as I said, it's a frontier of technology. A lot of it's new, so there's not going to be a lot of things you can reference. So you have to actually interview other people to figure out what their ideas are and write those down in the book so that they're all covered.
And when you write those ideas down, what I did when I wrote books is I would try to get some of my friends or people I knew who were experts on that subject to write a little portion of it. Is that what you did as well,
Mm.
or you kind of riffed off the page with them?
Well, I'll try to reword it in such a way that it's understandable to the reader. It's all about the reader and educating them. Um, so you have to put it into perspective. So I like to use analogies and metaphors so that they can understand, certain concepts of, in this case, streaming. But if there's a really good line, and I try to directly quote them in the book, um, and then thank them obviously in the preface about their contributions to the book.
Oh, good. So you mentioned having started your career quite a while ago. The place where you started your career initially was called iWaySoftware, and while doing that, you were doing web development. Is that right?
Not necessarily web development. They're like web services. If you recall the SOAP web services back then, I started off in writing basically APIs, web APIs for databases or data sources, and eh, eh, but this is all before REST, right?
So you were using
And
SOAP or
so
CORBA?
yeah, we're using this. Correct. And then I got to a point where I was managing about 4 or 5 adapter engineers. We call them adapters, or today we call them connectors. But um, all it really did was just wrapped a source so that you could perform CRUD operations against it, and it was typically part of an ESB or enterprise service bus back then. It was all about integration, right? And I really actually enjoyed that job, even though today I really hate the idea of writing connectors. There's just so many of them, and there's so many versions, and there's just it's just not good economics there because you really have to provide so many. Um, yeah.
Yeah, if there was one thing that Kafka did, I think that really benefited the community as a whole, it was to start standardizing these interfaces for let's get data out of your product into Kafka or Kafka API more correctly, and so that Kafka Connect that was an interesting part of that was that's I think that API is going to live as long as the Kafka API as well.
Yeah, well, I could see it actually going away. If you if you notice, Kafka has just become more of a protocol than a uh, a streaming platform. So if data sources or databases are all start to implement this Kafka protocol, it kind of negates the need for a separate connector architecture that pulls it out. You can already Cockroach DB kind of does it already. You could write a statement that actually emits changes to Kafka because it knows there's no protocol needed there, right? So a lot of these newer databases are trying to automatically incorporate the Kafka protocol so that these connectors aren't really necessary.
Yeah, that's what I mean. You could say the API is probably not going to be Kafka behind the scenes forever, or
Right.
even now, but that legacy that legacy will be interesting. Where we'll talk to people in 10 years, and they'll say, what was Kafka? It's a protocol, right?"
Yeah, yeah. I mean, look at Warp Stream and Red Panda. They all implement that same protocol, right?
Yeah.
There's not Kafka in the back.
Okay, so yes. So what I was going to say is the start of your career sounds very similar to mine. Of I was
Mm,
doing sort of web stuff, so that was why I knew about. Well, there's before REST there was SOAP, which was just this messy Microsoft thing. If nobody's ever, if the watcher hasn't seen that or heard of it, it was terrible. And then even before that, there was CORBA. And so as you kind of look at that, CORBA was really really ugly, and then SOAP was a little bit better, but it was still terrible. And then you get these gradual things of REST was a little bit better, and then we gradually get a little bit better over time. And I guess with enough time in the industry, you can start to see those improvements. And at the same time, you'll see some massive steps back, which is kind of odd to me, of saying, well, we knew about that. Why are we doing this thing again? Do you get that feeling as well?
Yeah, it's always a two-step forwards, one step back when it comes to technology, right? And you'll always get a repeat of some of the same tech ideas and technologies implemented in a different way, but the idea is the same, right? It's like music. you're repurposing, reusing some of the old ideas and creating new things.
So let's say somebody's watching this and I see a lot of people in web development trying to move over, or I guess back end development. What advice would you give them to get into real time or big data or data engineering?
Yeah, everybody's got to have a little bit of data engineering in their skill set, because every application provides data. Even if it's not directly, it'll create it indirectly with logs, because you always have to still monitor your application. So there's always going to be some kind of data in somewhere, and being able to share and provide that data to cons- to its consumers. Uh, that's it could be hard, could be easy, right? And they could be demanding. So you want to be prepared on how you're going to provide that data. And so a little bit of data engineering is always helps. So SQL, obviously important. A little bit of understanding of distributed architecture, what happens to data when it starts to go into these types of systems, um, and maybe a little bit of Python, so that you can kind of help prepare or uh, you know, serve this data to those that don't really understand it yet or know how to use it.
Yeah, I would agree with you. I think that there's a lot of foundational aspects that help us out or helped me out way back then. Of you understand data, you understand that value of data, getting that data from point A to point B. So understanding those fundamentals is important. I would also say that some of those parts that you talked about, you should have that SQL. Well, most of those backend people should have SQL, and so it's not a matter of learning that. It's probably adding some new skills in there. You eventually left there, but your title was technical director. What were you doing as that technical director?
That was kind of like a catch-all role. I had people reporting to me, and then when those people kind of got laid off, I was more into like research. Uh, if you recall, around 2008, 2009, everybody started to get into Hadoop and big data. So that was kind of my niche. I was learning sort of that stuff to kind of better understand how to integrate it into our data stack. That we were mainly just an ESB. How is that going to work? And how are we going to evolve to the big data world? So a lot of my time was spent understanding how that was going to work. Out of that came a product, um, the integration product that built data pipelines on Hadoop. And the way it worked was we had an Eclipse. I don't know how many of you still use Eclipse, but Eclipse IDE. You could we created plugins into this IDE so that you could drag and drop on these objects that create basically a data pipeline. But when you deploy and compile and deploy that, it was generating Spark code that gets deployed into, in this case it was Cloudera, but Hadoop basically. So that was kind of the path towards how I got to Cloudera. iWay kind of shifted in their their uh, some of the technologies they wanted to focus on. So they were moving more away from big data, and I wanted to kind of stay in that domain, and so I found myself going to Cloudera after that.
And you had been there for quite a while. I think was it 10 or was it 10 years?
Yeah, I think it was about 13 years. They
Oh,
were nice people. Um, a lot of times, that's more important than the technology itself. um, but at some point, you have to part ways because you don't want to be and you don't want to be complacent in the technology and your skill set. So I wanted to move on.
so let's say somebody's in that situation now. I see this pretty often. They've been at a company for quite a
Mm.
while. Things are either starting to stagnate in their career or stagnate in their technology stack. What would you tell them since you went through that?
Yeah, it's I have to say that you always have to keep learning. Unfortunately, I know you know it's comfortable to be able to do the job that you're doing uh, all the time, but technology is different. It changes, and it costs a lot of money. And if you're in that domain where you find yourself your skill set getting a bit older, um, you can get pretty lost in your career pretty quickly. So it's important to keep up. Um, and that's why I became a developer advocate. My mom was a teacher. I feel like a lot of my career when I went to Cloudera involved a lot of teaching because that learning curve from going, I guess, a simple engineer to big data, that jump from just to big data was really hard for a lot of people. Really, a lot of people didn't understand distributed systems, and then or even like Scala. It was and Python was still kind of new to a lot of people. It was a lot of technology to learn at once, and helping people to get over that hump. I think is important, especially my role, and I enjoy it. I like seeing people succeed.
So you made that jump to Cloudera, and we were talking before. You and I didn't overlap in our time at Cloudera, but uh, you have the same observations I did. The difficulty wasn't so much API or or big data in and of itself. It was the API. It was distributed systems. It was people wrapping their head around this whole different paradigm of of how you had to do things, and some people just could not do it. It was unfortunate. Uh, what else did you learn? What else did you learn during your time at Cloudera?
Um, so Cloudera, I, I really do feel like I they put me in the right path, basically. I spent my time learning Cloudera or Hadoop when I was at iWay and created a product that was Cloudera certified. And that got me into Cloudera. When I was there, they were ready to like throw me to the wolves, basically, or at least like, into the deep end of the water and help make me swim because they knew I could do it. I myself didn't have the confidence yet. And you actually had to gain that confidence of actually doing it uh, by hand. So I was in professional services. I got deployed to many big name companies to build big solutions, and I would go in there and deploy Hadoop and set up Kafka, set up these complex pipelines, delved into some machine learning in Spark, and put things into production. Things would catch fire, and you would have to put them out. You'd have to learn by yourself, right? And with the backing of some of the principal engineers at Cloudera. It was a different way of really understanding how to use technology and deploy technology at big companies. as a consultant. It's scary, but it gave me the confidence to really understand and learn this stuff. And people came to me with questions and so forth. So um, it was great. I loved my time at Cloudera, and I really thought I learned my chops there.
Yeah, I'd have to echo that too. When I tell people about my time at Cloudera, I learned how to run a company well. I think you were there after Mike had handed over the reins to man, what was the new CEO's name? I'm blanking on his name, but
Um, yeah,
the
I don't
the
remember
the
either.
CEO, yeah, the CEO who came after Mike, and yeah, he was also a good guy, but I think I learned the most from Mike Olson. Uh, I still keep up with Mike every so often. He's still out there and about, still poking his head into things.
Yeah, yeah. It's always nice to see him pop up out of in social media.
It is, yeah. So you went from Cloudera to Confluent, and I'm guessing you were like a lot of people at Cloudera. You were hitting those Kafka deploys after Kafka deploys, and you decided to make the jump to Confluent. Is that about right?
Sort half right. I was seeing a lot of Kafka happening in some of the solutions when I was in professional services at Cloudera. But many people started to move away from Cloudera because we were starting to see the effects of it not jumping to cloud early on, right? And we were seeing things, companies like Databricks and Confluent embracing cloud early and going all in on cloud and SaaS services. Um, Also, a lot of my colleagues went there, so uh, a few things affected that. The Kafka, I think, was started to become more ubiquitous, and I think SaaS providers or SaaS approach of selling software was more becoming more important, and a lot of the influences that I from my ex colleagues at Cloudera were pulling me into Confluence. So all three of those kind of factored in my decision to go into Confluence.
So what did you learn about the product at that point?
Well, when I went to Confluent, it was I was coming from Cloudera, where you have all these different systems that you had to know, like HDFS, Kafka, HBase, Hive, and Impala. All these you knew you needed to know how to use them, deploy them, secure them, etc. And then Confluent was just Kafka. It was hard for me to understand, how can just Kafka be enough to run a business. It turns out it was enough, and probably more so. Um, what I learned about it is how to really understand how these big data systems got deployed into the cloud, how how the cloud was affecting the business, how you earn money, how how companies, how you sell cloud, right? So it was a lot of cloud mixed into what previously, before when I was at Cloudera, focused on on-prem systems. Cloud really affected how I saw distributed systems and big data and data pipelines.
Yeah, it's always funny. A company called Cloudera, the Cloudera, didn't really embrace cloud, and it caused a lot of problems for them as a business. I would say
Yeah,
early on. So I did a lot with early on with Confluent, and they were initially very on prem, and then they definitely got that. Oh, we need to be cloud, and that was, I think, when a lot of what Gwen Shapira brought there of, hey, we do need a lot of cloud here.
yeah, yeah. But by the time I got there, I came after you. There was already a cloud service. It was just their on-prem deployment deployed into the cloud. It was not multi-tenant yet, so it was very expensive. And like, 'cause there's a huge difference there. Like on-prem, you don't think about the number of nodes you care about or how much your throughput is between these nodes, and um, that's less of a concern so much. Obviously, the this the capacity of the cluster needs to be able to handle the data you're putting through it, but um, it was not so much of a factor that it was in cloud. So you had to actually rethink how you were going to do, even sell and propose solutions when cloud was in the mix. But yeah, we had to do everything kind of over again when we deployed things into cloud.
Yeah, it actually brought a memory back of when if people are rewinding their minds back to that time, there's this whole thing of cattle versus pets, and your Hadoop cluster at that time was very much a pet, and your Kafka cluster at that time was very much a pet. They had names. They had to be up all the time. They had to have very high uptimes. And I think the issue for Cloudera was that the cloud changed their Hadoop cluster into cattle. But up to that time, there's no way that you could change your Kafka cluster into cattle. It always had to be pet.
Mm.
And I think that was I think even to this day, you can't really do that behind the scenes. Obviously, Confluent's doing a bunch of things with routing. I can't remember the name of their product that does that, but behind the scenes, it's going to different clusters. But that's pretty interesting that there was this whole shift that Cloudera couldn't do. Because if you change your Hadoop cluster into cattle, it didn't matter if your whatever died. You could just bring your cluster back up again, for example, or there was a lot less need for the sorts of things that Cloudera was providing, unfortunately.
Right.
So you,
Absolutely.
so you went from Confluent over to Decodable, and as part of that move, you went into developer relations. You mentioned that before. Why did you make that jump, or both those jumps, actually?
Yeah. At that time, I started writing a book based on my experience at Confluent and understanding what a data mesh was. But I didn't want it to be only from the perspective of Confluent and Kafka and Confluent's preferred technologies. At the time, Confluent was not a Flink company, and I really wanted to into a company that provided Flink as a service, which was Decodable. It gave me a different perspective, understanding how, well, number one, how Flink works, and how it differs from, say, Kafka Streams or KSQL DB, and as far as scale and deployment, right? Uh, and I wanted to add these things to the book. I wanted to be able to say that I covered as much as I could as far as streaming and when I'm talking about a data mesh, a streaming data mesh.
Now you mentioned wanting to use Flink, and you came from that background at Confluent, and so for people who don't remember, at that time Confluent was 110% behind Kafka Streams and KSQL DB. I personally have written pretty extensively about it, so that you don't have to say your thoughts there. But KSQL DB was really terrible from the very beginning. Absolutely terrible. Should not have been used. Should have never been out there. And then Kafka Streams, kind of, sort of, but I think it's a very limited use case. I always personally put forth Flink as the better solution there. I'm curious what your thoughts were and why you wanted to do that.
Well, there was an interesting thing when I joined Confluent. A lot of the people that I spoke to and a lot of the go to market content is focused on the operational side of Kafka. So the way people tend to use Kafka, especially nowadays, is that cloud application or your user facing application is providing some piece of data, um, and gets sent to Kafka. So that's the operational side. So there's a lot of conversations around microservices and event-driven architecture, all around how to build your applications and send your data to Kafka. The second half of that story is like getting that data to your analytical systems and providing real-time reporting. And there was not much in as far as like go to market and content and conversations in at Confluent that really spoke to that side of the pipeline. Flink actually lives quite nicely in consuming data from Kafka and then providing that to the analytical systems. And that's what I really wanted to kind of cover and to make sure it was part of the book. If you recall, if you know a little bit about data mesh, initial intention by Jean-Marc was to have it be an analytical solution, providing your data to analytical systems to be served in analytical use cases. Um, and so having only half the story from Confluent was not enough. So and the solutions that I tend to see when it comes to stream processing, KSQLDB, if you were brave enough to use it, or KStreams, they they were deployed as microservices. So I attributed them to be deployed on the operational side. You absolutely could deploy them on the analytical side of the your data platform, but a lot I still see them mostly in the operational side. So I wanted to be able to cover what it would look like on the analytical side uh, of especially in a data mesh context, that side of the architecture.
Okay, we'll get deeper into the data mesh in a second into data mesh and streaming data mesh in a second. But
Yeah.
after that, you went into doing freelance. What sorts of things were you doing during that freelance time? Was it more writing?
Well, I did some side work just for extra cash, but mostly the freelancing was to help me get out of my comfort zone. I had the opportunity to do some um, other things, so I guess I would just do them just to see to make sure that again, to keep my skill sets up and to make sure that I wasn't neglecting or ignoring a part of technology that might you know bite me in the butt later if I didn't pay attention to it. So ever so often I'll take a job here and there just to see what that technology looks like and finish it.
So that comfort zone, why did you feel the need to get out of your comfort zone?
It makes you feel more confident. You'll see where your weaknesses are, what areas you need to study. Sometimes you'll just realize, hey, this stuff is not interesting to me, and I'll make sure not to. I know that's not a technology I will be anybody will ask me because I'll just admit that I don't know anything about it. It's all about really learning, and because you know where you stand. I had this conversation along like about almost 20 years ago where somebody we were building we had a CI/CD pipeline where we would run a bunch of tests, a unit test against our software, and people didn't like to see the errors. And I told them it's better to know about these errors than not to know them. So that's basically what these freelance jobs were. Is like I want to know what I'm weak at and what other technologies that I might actually be interested in.
Interesting. It's almost like you're applying a distributed systems concept to your life of figure out where you're weak at, figure out where you're going to break, and try to fix that before you break there. Well, that's
Right,
interesting.
right.
Okay, well, after that freelance period, you went to StarTree. Could you tell me a little bit what StarTree is, please?
So StarTree is the company behind the open source project Apache Pinot. Apache Pinot is a real time OLAP database. Um, Some similar systems could be Apache Druid, ClickHouse, a lot of those other OLAP systems. But Pinot is one of these more advanced um, uh, OLAP system that came out of also came out of LinkedIn. That was intended to work with Kafka to provide real time analytics to front end applications.
Okay. And why did you decide to join them?
It's interesting. It's the last mile of real time um, use cases. It's funny because I like to joke about this a little bit. I like to say that my career came from started at Cloudera, then to Confluent, then to a Flink company, Decodable, and then to uh, StarTree and Apache Pinot. If you follow that, that's initially it's a batch system, and then this real time analytical system from Kafka to Flink to Pinot. Um, so that's where I wanted to go. That's the complete. I feel like the complete pipeline from source real time source data to real time analytical serving of data to possibly those same end users. Right?
That's interesting.
Um,
You
yeah.
use this term "last mile." That's the term that I actually use when I would when I taught Kafka. There was a first mile problem and a last mile problem that Kafka solved really well, and that was part of why I worked with Confluent early on. Is that I saw at Cloudera this inability to handle that first mile problem of small data, small real time data. People would try to throw HBase at it, but HBase wasn't the right thing for it. A distributed pub sub like Kafka was the right thing, so it solved that first mile problem. And then there was that last mile problem of, okay, you've got all of this data. How do you get this out to something that's useful, that's usable by somebody else? So that last mile problem is important, and so that's what you're seeing StarTree being, that ability to do your last mile efficiently.
Correct. And there's a spectrum of SLAs when it comes to that last mile. Some people want it a lot sooner or more real time, and others are okay with it being generated next day or end of day um, analytics. Uh, and your technology changes as you move up and down that spectrum. With Pinot, you can actually do both. You could read from your batch lakehouse systems, as well as read from Kafka. If you're familiar with the Lambda architecture, you can bring batch and streaming pipelines together in a single place for real time analytics on Pinot. So you could see real time data in the context of historical data and feed that to a front end application um, in real time. So you may not need real time data. A lot of these things, a lot of the applications there that you see can be absolutely supported by batch systems, but real time. We live in a world where um, data and information is on demand immediately. There's a dopamine hit when you see that information. Like how many times your profile was viewed, or how many clicks, or how well are we performing? Are we okay today? Where are my problems in the system today or my business? Um, that information provides you could actually do with Pinot because it provides you with the assurance that everything's okay, or the assurance that you could take something on if there's something's on fire or something. Yeah.
That's interesting, and it is interesting as well. You talked about that you've went through the whole stack in each level of depth. But it's also funny that Cloudera was that company with everything that then became all these other companies just doing one thing. And I've
Yeah.
always wondered, was that Cloudera's downfall, that they were trying to do everything, that they were trying to deal with so many different technologies at once and couldn't really focus on any one. But at the same time, I still think that there's that need for all these technologies to work together. I still think that for example with Pinot, that Kafka Pinot integration is just one piece of the puzzle, and so it's left the companies. It's left to the companies to say, okay, well, what's missing on this side? I have to go take this piece and that piece. Is that your take as well?
Yeah, I think with Cloudera, I think there was just way too many zoo animals there to take care of. Um, and so it's really hard to, I'll take a step back. So if you think of, if you compare Cloudera and say companies like StarTree and Confluent, um, the it's Confluent and StarTree, they really focus on the system that they are providing, just that one system, and then they try to do that really, really well. And in fact, they go beyond where they create a go-to-market where showing you and telling you why just the Kafka is enough for you to, why you just need a Kafka, and everything else kind of falls away, right? Um, I think at Cloudera, there was just way too many things to put together. It was like an n squared problem, and never really deep focus into any one technical solution, right? Um, Plus, coupled with uh, not it's this lack of cloud, I think contributed to the to his downfall. Um, but I mean, I wouldn't say a downfall. They're still around. They're still, they're still using. A lot of companies are still using Hadoop and the technologies that Cloudera provides. So, but I think there's a whole lot of focus on the individual systems and how they provide everything, in the context of real time and big data.
And that's probably what got you so interested in streaming data mesh, because how do you take all these systems, create something that's usable out of that? So let's talk about more about this streaming data mesh, and we will talk about start by whiteboarding this out. Perhaps the initial question is, what is data mesh and what is streaming data mesh?
Yeah, so a data mesh is just uh, a way to provide, this is data platform or patterns to use to serve data to other many consumers of that data. In a data mesh, there are four pillars. There are your domains, which holds or owns your data. A data mesh is a decentralized approach to managing data, and your domains now control uh, the ownership of of your data is owned by the domains that most likely created that data to begin with. And since the ownership belongs to these domains, the assumption is that you have many domains that produce their own data products or produce your own data. Now you have to treat data as a product. So you have data products. So what that means is that your data is of high quality and can provide and has provides a metadata about your data. Um, so now you have these pillars. This is a decentralized over here. Um, so now that your data is decentralized and belongs to the domains, um, you have to create high quality data, data products so that other domains can consume your data, including the analytical domains. And then, so what you would have to ensure is that you have um, the the systems that makes this easy for you to use. For instance, um, you need the tools to make it easy for data through your domains to create data products, right? So let's see if I can find an image here. To provide and because I'm the worst drawer. So you need yeah. So you need to have the tools
I'll
to
just wait till the
allow you to
swimsuit
provide.
competition.
I'm sorry.
I said, just wait till the swimsuit competition if you're bad at drawing.
Oh. Yeah, so you need the tools. So you need the tools to allow the domains to create your data products. So it could be a CLI of some kind. You'll need like a schema registry. All the things that you need to do to be able to create these data products. And then with that, you need a federated governance, right? And this is since it is a decentralized data system, you have these isolated autonomous domains sharing data with one another. Um, they need to play well together. You need to be able to share the data in a way that is that can be monitored and checked and so on. So that's where the federal data governance um, uh, it allows for like uh, a harmonious mesh, right? It is the mesh that allows the communication between systems be easy and safe and secure, right? So I kind of wrote this chicken scratch here just to get you started with what a data mesh is, and I'll switch to a
Well,
new pane here.
let me give me a second. I have a few questions for you. So,
Oh yes.
data products. This is an important part of data mesh. Probably one of the reasons why I found it very interesting. And what is your definition of a data product in this case?
Well, data products in its simplest form is just a the data products that you have in your domains that you're exposing out to others to use. So typically, in in data systems, or say I have an application, I'm producing data, I put it into Kafka, and then the analytical side of the business takes it and uses it, right? But they tend to have they need to manipulate it. They need to either join it or change some types or check types. They need to clean it up and prepare it so that the analytics you provide at the end are accurate and clear and understanding, right? And they match what is expected and they match what you're seeing as far as is happening in your systems. Um, so the idea of the data products is that a lot of that is already done for you so that you can just use your data that's coming from these domains so that these other systems don't have to clean it up for you and to be used. For example, one of the reasons why data mesh is really fascinating and intriguing to me is that I worked as a data engineer for a really long time. And a lot of this responsibility of providing data from many domains falls on like one or two data engineers. And that they are not going to know the details of they're not experts. They don't own that data. They only receive it from these domains. So they're not going to know the important information that needs to come out if they need to either change or normalize data somehow, if the format of a phone number is wrong, or if data needs to be hidden or secured or omitted somehow. All that is really not known by these centralized data engineers that end up creating the data for an analysis later. Only the domains really know. They're the ones that have the expertise that goes along with that data. So you have this centralized domain data engineer, or a few data engineers that are trying to make these decisions, trying to find where this data is coming from. Where in this case, in a data mesh, the domains now are responsible for providing and data as products, so that is of high quality, is already secure. It already provides the metadata that's needed by the consumers so that they can consume it appropriately into their systems.
So I'm just kind of drawing that out where so that people can visualize this concept of the decentralized versus centralization. So in the scenario that Hubert was just talking about, you have these various teams that have the knowledge, they have this domain knowledge, and they're getting their data engineer to output it directly. But that data engineer probably doesn't have enough of either the context or the business context to do that well. But if you do this in this decentralized way, it's the domains that are responsible for outputting that. So here we have our domains. This domain is responsible. This domain is responsible.
Correct.
Now, one common question that people talk about is a data product only exposed with one technology, or is it multiple technologies?
So data products could be exposed, published, I would say, into to the mesh, however you would like it to be published, right? Um, the difference is that the SLAs or the rules or the contract that goes along with that. We haven't spoken about data contracts here, but when I wrote the book, the idea of a data contract wasn't really identified. So when you read streaming data mesh, I describe data products as a data contract. Um, but it's basically the contract between the producer and the consumer of that data. So when, say for instance, if you publish a data product into the mesh, consumers should be able to know you know what is the freshness of this data. Is it real time or is it a day old, or etc. How much of it what has been done with it? Has there been any enrichment? Is it secured? Did you remove it? What are the schemas, etc. And most of all, what kind of like throughput am I allowed to consume it by? If I'm uh, hitting it with, let's say let's say it's Kafka and it's only got 4 partitions, and I'm hitting it with a lot more than more the consumers, I'll know that I can't consume more than the 4 partitions at a time, uh, and having more threads or things hitting it, instances hitting this topic is not going to get me more. So that kind of information will be important in as far as like consuming the data, and how to build an integration with it.
Excellent. Okay. So yeah, let's continue on. Let's go to number 2, and so you can draw out what you were wanting to draw out next.
Yeah, let me go to that page. Yeah, that's the last 2 pillars are the tools. I like to call them tools. Ijama called them self uh, service services. Basically, this enables domains to self-service themselves to be able to produce data products. Um, if I'm a domain engineer, let's say I built a web application or a phone application, and I don't know a lot of data engineering. And I know SQL because I have to get data in and out of a database, but I don't have any other tools. Like for instance, I don't know. Like I don't know what Kafka is. I don't know what Flink is or KSQL DB. These are things that are typically associated with a data engineer. So it's important to be able to have the tools that make it easy for a domain engineer to create and provide a data product. And this means that like command line applications might be good for them to deploy. I can say, I have uh, a CLI tool called DM for data mesh, and then a sub command that says, publish, and then my data, and that single line publishes a data product to the mesh or something like that, right? Um, a lot of the tools that you would want to have that are self service should probably have support SQL, right? If I and these data engineers need to be able to, at least know SQL, so that, or these domain engineers need to know at least SQL to be able to source data from, if it's a database, and then maybe put it into a place that gets where that data gets deployed to the mesh. Beyond this, maybe there's Python here, but beyond this, um, this is really the only real interface that should be provided to domain engineers or data product engineers, right? Beyond this, I think it gets harder for domains to adopt a data mesh, because it would involve you know a lot of learning that they may not have time to do, um, and a lot of monitoring, etc. You want to be able to just limit the work they need to do to just these types of tools, and to be able to still be part of the data mesh. Does that make sense?
It does, and it kind of goes with what I've seen as well. Of I would say that's one of the common issues that I see with people trying to do data mesh is thinking that your average software engineer even can do the data engineering behind the scenes. Distributed systems are a
Right.
very different beast. Data systems are a very different beast than software engineering. And I say that having done both, it is a very different part. So if you're going to try to expose, I would agree with you that you try to expose the bare minimum or the the simplest parts to the rest of the organization.
Exactly. The last pillar. Let me make sure that this is an L because it looks like a two there. Um, the last pillar is the federated data governance. So as I said, it's a mesh. Domains are sharing data to other domains. In order to have a harmonious mesh, you need to have some kind of governance that allows you to secure, um, and that has the components for communicating uh, data between each other, right? So there's going to be some kind of possibly APIs that allow you to say not just secure, but possibly, increase uh, scale, right, or capacity, um, um, from low to high. For some systems that could be really hard, especially Kafka. Um, but these are things that will allow you to just basically create a harmonious um, uh, data mesh. What I like, the way I like to kind of break this down is follow the like local and state or federal governments in a government in the country, right? So if you think of like the federal government, like the overarching government, and then maybe you have your state government, and then maybe let's just stick with that the state government. So you have your federal and your state government. So you have many states here. These are akin to your domains, right? Um, so each state can have their own governance, but they still have to follow at least the the basics policies that the federal governance provide. What you do in your state is in the domains is really up to you as long as they adhere at least meet the federal governance. Um, and in fact, when you look at this, um, this starts to build a little bit of an architecture. Um, I don't know what your next question is, but this in the book I do talk about a control plane and data plane. So these following the federated the governance, you can actually implement a control plane that has all the APIs and has the policies that define your data mesh. And then
Did
in
you
your
did you
domains,
switch
that is
whiteboards, or are you on the still on two?
it's
Oh, okay, it just
it's
popped in.
taking
I'm sorry. Okay,
yeah, it's
go.
taking a second for it to come. Um, yeah, so your state um, nodes here in the governance actually hold the data, right? So they may have specific uh, governance that are only applied to that domain. Another domain may have a different set of policies for their own data. But when you start to communicate between each other, um, it's like a control plane and a data plane. The connections between, let's see if
You're
I can
talking
do a
about
different color here.
communicating between the two states, as it were, or domains.
Right, right. So that's handled by the federal data governance. The way you connect has to be defined common. Like you could have a Kafka, or it could be some other, batch approach of sharing data. That's because the federal the federal or the control plane really controls the connectivity between the domains and can sever even some of these connections between domains if they don't follow policy, or if there's something that's happening that's you know or if your data product is causing issues in the harm causing issues with the harmony of the mesh somehow. Um, so the control plane has control of the mesh itself, but the domains still have autonomy within themselves, creating these data products as data leaves these domains to other domains. That's where the control plane or and this the federal data governance policies get applied to it. Right. So let's take for instance, let's say the state or this domain here. Let's say it's in the UK, right? Let me just do an erase here. Let's say this is a European Union somewhere, right? And this is there's a domain in the US, right? Sending data from here to here, obviously there's going to be some GDPR issues. So you're going to have to apply GDPR, PR policies here to check on these types of integration or consumption requests, right? Here. So what are some of these policies? Well, we're going to the EU, the EU domain is going to have to check to see if there's any private data, uh, change that data or omit some of that data when it provides this data to external countries. So all these policies have to be part of the control plane or the federal data governance. So you can start to split up these policies as needed and apply them between domains as needed when they start to create these connections, forming a data mesh.
Excellent. So one of the questions that I think would come up here is those who've, let's say, read the book, they saw that the data mesh wasn't specifically technical. There was no technical mandates to use technology X, Y, or Z, and or batch or streaming for that matter. Why does there need to be a streaming data mesh, or can you just say it's data mesh?
It is just a data mesh. At the time, the data mesh community was very high level academic level conversations. Um, no, any one particular technology was allowed to just be say, to say this is how you're supposed to implement a data mesh. I knew how to implement it as streams, and so I wanted to provide an example of how to do it in streams. Um, I may not know how to do it in any other ways. So you could actually, the intention here is to take parts of the ideas that are provided in the book. And if there is a data product out there that you want to expose as real time or as streams, you could do so using some of those technologies solutions that are provided in the book. In no way did I say that a data mesh should be implemented as only streams. But there is an advantage of doing it in streams, obviously.
I see. So the book could almost be named, instead of streaming data mesh, it would be data mesh with streams or using streams or something like that. Doesn't
Yeah,
sound as good, but okay, that makes sense.
yeah.
And so now that you were just talking about that issue of the of it being pretty academic, pretty high level, which I would agree with. Now let's take it down and talk about some of the implementation of how you might do this with technologies. So let's go
Mhm.
to 3. And so how would you, what are some of the technologies that we might use in the streaming data mesh?
Right. So let's start with the domain itself. So, and there are two types. The way I like to bring up a data mesh is it's best implemented when you follow domain driven um, design uh, patterns, right? So in domain driven design, you're creating these entities that define your use case or your domain, right? So let's say there's like, let's do clickstream for example. You have like a user that could be an entity. Sorry, just taking a
You're on
second for it to
4,
load on your
I
screen.
think. Um,
Oh, I am.
yeah, go to 3, please.
Oh, my bad. Sorry. Let's do domain here. So let's say there's a user, and let's say there's a product, right? So these are two entities that you may define in a domain-driven design. And then there's uh, an event, right? So a click, right? So what they call these when you create these like the user and the product could most likely be in a database because there's a finite number of these products, right? And there's a finite number of possible users you can put into a database. Um, a clicks, there's an unlimited amount of um, these records, right? You can put them into a database. You're going to run out of space pretty quickly because this is going to come at you at a high throughput. So you'll need, if you put it into a database, then you're going to have to implement some kind of retention. Because there's just no way, that you could be able to hold all of that data in a single database. Most likely you're going to put it in a topic, right? So most likely you're going to put it in here that has already built-in retention, is ordered, and so on, right? So just to think about the types of data that you're accumulating, even logs, like your log files that monitor your application. These will also go into things like a topic. You put them into a database, you'll reach capacity really quickly. You put it into a topic, then you have a way to actually save these and then and phase them out with retention. So that gives you two types of data. Two types of data are like these are like data that can change, right? Because you could change a user's address, a phone number, you could change the product number or even delete a product, right? So users and product, those are data that can change. So it hasn't refreshing your page yet. The ones in the bottom, these are append only events. Right? So each one is unique. Technically, append only events are only insert records, right? The ones at the top change. You could think of those of like being updated, inserted, deleted. Those are the types of change records that you would see. So there are two types of records from your domain that you're going to get, or two types of data you're going to get: change and append only events. You'll need to understand how to handle each one. Already, we know that append only events, that's going to grow really, really fast. So the way you store that data is going to be different. And here, since I'm suggesting a topic, because it's naturally meant to handle that type of data, append only data, because it has retention. In the database up here, you'll need to implement some kind of CDC or change data capture um, approach, where you can use something like a Debezium, or there are many different types of CDC connectors that will take that data and put it somewhere for you and for you to consume in your analytical space. If we're going to do this all in streaming, both CDC data and click and log data will end up in a Kafka topic, or a topic on a streaming platform, right? So you can actually put this data into here, and the topic down in the bottom here is already in a topic, or already in a so this is your change data here, or sorry, this is your append only data there, and this is your change data here, and I'll change this into logs, right? So now at the domain level, we have an understanding of the type of data we have. And when you go into something that can pull that data in, you understand how they will behave. So I'm going to go to, I've run out of space here. So I'm going to go to the second, or the fourth page. I'm going to delete that. So here I'm going to use Flink. In the book, I use KSQLDB because it was just simple. It was all part of the same ecosystem. I didn't have to make it more complicated, but I'm going to use Flink here. So in Flink, I could create, when you deploy Flink, so we're still in in the domain. And Flink here is just another tool that will self-service the engineers, the domain engineers, to create data products. So I can now create in Flink. There's a Flink SQL, so I'm just going to use a Flink SQL here. So I don't have to write it in Java or Scala. I can just use a shell that talks to a Flink cluster. That Flink cluster is unknown to the domain. Is handled by the control plane, but and is provided by the control the central mesh. It's just a tool for you to be able to use. And then this in Flink SQL, I can create a SQL that pulls in data using CDC from my, let's say, Postgres database, right? So I would create, what was it, the user table. So we have a user table inside of our Postgres, and then we define the schema there, and then we could define a connector and a set of other parameters like the database and the table name and so on. And that itself will create you a table inside of Flink called users. You do the same thing for a product table. So now you have two data products, potential data products inside Flink for you to use. You do the same thing for your click stream, right? In this case, the connector will be a Kafka connector or whatever streaming platform you're using. So now you have three products: your click, your user, and your product inside of Flink. So what you could do is actually just define another table. So this table could be user K for output Kafka. This could be click for K, and that's another click stream for Kafka. And then expose those Kafka topics to the mesh for others to consume. You can also, sorry, go ahead.
Oh, no, go ahead.
Likewise, what you could do is enrich a click stream. So you can actually join in Flink a user, a product, and a click event, and provide that as a enriched, I'm going to just preface it, ECK, enriched click to Kafka. Now you have a more elaborate data product, right? So depending on what consumers need, do they only need the users of your application? Do they only need the products of your application? Or just the click event without the detailed information? Or do they actually want the enriched click event that that also has a user's name and the product name, so that the consumer doesn't have to perform that join, right? Obviously, this is going to be a more expensive data product. Part of the federal governance is to be able to handle the economics between domains, right? Here, you could be monitoring usage, what it takes to create this ECK data product here, and charge back to the consumer of that data product the resources it took in order for it to be served to that consumer. right? Like usage-based billing, for instance. Um, yeah, so this is how you would create a possibly create programmatically the data or move the data from the actual sources to a streaming platform that can be consumed by many other uh, domains.
Good.
So
Uh,
at some point, that's yeah. Sorry, go ahead.
Oh, I was going to ask a question so that one of the common questions here is this join obviously is technically here in the Flink side, and this is
Right.
definitely a data product that is very common. One of the problems, or I guess the questions that is still outstanding I think in the data mesh community is who in the domain is responsible for this. So there's probably maybe there's a separate team responsible for user, separate team for product, and a separate team for click. Who owns this ECK now?
So in this use case here, the domain still owns this data product. They would know they have the expertise to know how to join a click to a user and to a product,
But what
right?
I mean
It
is,
would
let's say there is a domain here. Let's say just arbitrarily user and product, and there is a separate
Mhm.
team domain doing clickstream. So this clickstream is coming from some
uh,
sort of homegrown website, and then this other data was coming from a CRM. Let's say
I
who owns
see. I
this?
see. So if there are two domains here, the top being one domain, the bottom being another domain, um, the join belongs to the uh, the the consumer of uh, um, the three products, the data products. So let's say, for instance, I'm going to assign these domains. So DA for domain A, DB for domain B, and then DC for the consumer. Okay, so I'm going to circle these guys. DA is providing the user and product, DB is providing the click, and DC is consuming all three products: user, product, and click. The join would be the responsibility of the DC domain, meaning it'll have to pull in all the data first and locally create that join um, to be used internally. If if others want to use the output of that join, the ECK, then DC here, the domain DC has the option to expose the ECK topic to the mesh.
Now the question here is. Will DC have enough domain expertise about user and product and click in order to create this correctly?
The assumption here is yes, because we're saying here is that DA may not have the only has the expertise for user and product. DB most likely will have some kind of information from user and product because click is going to be a condensed record. It will probably only have the user ID and the product ID in it. So they may have all of that knowledge to create that join. But it's really, but they don't have the resources. They're just providing this click event, right? They could be instructed to create an ECK join, create that join, enrich it, and provide it. But if that data product is not available from domain DB, then it's up to domain DC to just create that data product.
I see. And you brought up that interesting, and I think not just conceivable, but I would say probably the logical conclusion of domain DD using it and domain DE using it. And so
Correct.
your solution there was that DC would be responsible for this join and could decide to give them access, which would mean that if they didn't
Correct.
decide, that DD would have to make their own and DE would have to make their own, which would gets you into one of those catch 22s of data of now we've replicated this in all its overhead.
That's right. So that's the autonomousity of these domains. They can do whatever they want with this data. If you want federal data governance to come into your domain governance and check that, you can allow that. Here, the assumption is that you want these domains to do what they want to do, and have governance only be applied between domains.
Makes
Does
sense.
that make sense?
Yep.
Yeah. Alternatively, in the future, DB down here could create that new data product, ECK, right? Themselves, and expose that data product to everybody else. In which case, um, there would be two data products. If DC created its own data product, doing the same, and DB also as well, I would probably lean towards the DB's data product, because they probably have that expertise. They know that the click has a user ID, and the product also has a product ID. They probably know that join. They probably should have created it in the first place, but ensuring autonomous domains, you want to just give them that freedom. The market, the data product market, will probably migrate towards DB's data product, and DC will lose their consumers, and eventually have to tear it down and not
Yeah.
provide it anymore.
Yeah, I would agree with you there. So what I would do in this sort of situation is, as you're doing the meetings with DA and DB, you're going to probably see the need initially for join domain data products, and I would definitely look at DB as being the one, because if I were to guess, this DA team is probably more DBA, more data warehouse people, just
Hmm.
keeping an eye on user and product. And whereas the
Right.
clickstream would probably be much more akin to a have more data engineers, or much more closer to a data engineering team, and could do this. So you might think about it along those lines of skills of team. If this team is more data warehouse, more DBA, it's probably not within their forte to do this. Where DB maybe actual real data engineers and can do this. And so that would definitely be what I'd be looking at for there.
Yeah, that makes sense.
But obviously, a hypothetical, everybody watching this, your mileage may vary, but as you think through this is often that next logical step that people say, oh, we didn't think about that. Well, it's
Hmm.
inevitable that you're going to want this, because joining this and joining this and joining this, it means that either people have to reach all the way back into some sort of database to pull these out, or you have three different joins of the same thing, which doesn't get you anywhere, because now you're loading a cluster rather than the database. And these three-way joins are expensive. They're not
Right.
for free. Although
Right.
Flink can do them efficiently, you could probably, depending on the size of these, you can instruct Flink in how to do that join, whereas it more on the map side rather than after a reduce.
Correct. Correct. So after this is actually, it gets interesting. I mean, it looks like that you have the data product. Let's say you've defined that the some metadata somewhere, like a schema registry, but there's still a lot of information here that's missing, that creates this mesh. If I go to screen 5, you do need a data catalog, um, to register all of these data products. So you have your, what was it, user, you have product, sorry, product, and then you have your click, and now you have your, what was it called, the enriched click in Kafka. Sorry, so these all have like this prefix on Kafka, or suffix. So so you have some metadata here. So the idea is that for other domains and other even analytical domains to be able to look at these and see that, understand where this data came from, so they know which domain they came from. Um, if they're protected, the user is not showing any secure information or social security number or like the credit cards or whatever. Um, and the schema is also provided there. But how can I actually? Obviously, needs to be a place where I could request access to the to the data product, right? So it's not just you go there and start using it. You actually need to have a workflow and say, hey, I am domain XYZ, or in the previous page, I am domain C. I want to consume user K. And that request goes to the domain that created the user product, and you decide, that domain decides whether that that domain is allowed to consume that product. There are a lot of things to consider here. Throughput can't, if there's multiple downstream consumers consuming data from the user K, will the infrastructure be able to handle yet another consumer? In here, you may want to show like metrics, or what are the SLAs, right? Um, there's going to be obviously a schema. Oops. Um, and so on. So if everything checks out, and I look at your metrics and your usage, will is it really high that I would be worried that if I started consuming from this data that it might fall over and somehow affect my part of the business, right? So all these things really need to be considered and read upon. It's not just connecting to this data product and then go. There is a workflow, especially if there's GDPR. Some policies may not apply to some other to some domains. So if I'm within the country, or if I'm somehow closely tied to another domain that they could share more sensitive information, that might be part of the logic here in the data catalog. You may want to say, if you are outside the UK, you will get a different type of data product than the one that's being defined here. So so there's a lot more to it. There's a lot more communication between domains than just technically. But there, when you publish this, I want to be able to write all this in a single like manifest. And in the book, I use async API. In it, you could define the connection, the schema, and a few other things. You can put tags, you can put descriptions, you can put links in it. So and then you could, and async API extends Open API, which is previously Swagger. So you could actually use a tool that supports Open API and deploy an async API and have a data catalog that shows you all the information that you would need to know about this data product. But this data product happens to be not a request response REST API. It happens to be an async API that is fed to you via Kafka. So it's a nice approach to publishing data products.
So, as somebody's watching this and they're thinking about this, why do you think they should go embark on this change?
It's a way to create a harmonious data mesh. It is all about making a healthy data mesh. If you want to be part of the data mesh, then you have to do your part. and being able to provide something like this that's easy for domains to publish. All they would need to do, you could definitely have tools and self services that automatically generate an async API from the data products that you create, and then have all that be available to a data catalog that can read, and then where consumers can shop for data products. Right? It just makes it simple.
Okay. What do you think is next for data mesh then?
Um, so data mesh, if you notice some of the conversations around data mesh, it's become less of the mesh and more focused on data products and more so about data contracts, right? I think um, I think it's the first positive step into ensuring that um, these contracts are still, so these contracts, they kind of cover two pillars of the data mesh: the data product itself and the federal data governance, right? It allows you to agree upon uh, sharing of data, so that the mesh is harmonious. The other parts of the mesh of a data mesh, like domains and tools or self services, can be generated after you've defined what you need as far as the data contract. So if you focus on data contract and less to the mesh, because the mesh is like the whole platform and architecture that goes along with um, that pattern. If you just focus on the data contract, then you're covering at least the data product and the governance itself, which is probably one of the more important um, parts of starting a data mesh. You could always create the the self-service tools, and domains are by default created when you have data products, assuming that they are you're following the decentralized approach.
What sort of suggestions do you have for people who are trying to get data mesh adoption at their company?
Um, I think the number one thing is that you know ensure that you have a reason to go to use a data mesh. If you only have one domain, or well, maybe one or two domains, and you have like an analytical, it's not much of a mesh. It's only like a few lines that are connecting multiple domains in the uh, in the enterprise. Does it worth um, uh, building a whole mesh to do that? Probably not. You can just talk to one another. There's only three of you. Um, Once the number um, of domains starts to grow, there may be domains that live in the other side of the world that you've never spoken to, or more secure domains, or there. Then once it starts to get out of hand, you may want to kind of figure out how can I make this easier for myself and for others to gain access to this data. So that's number one. Make sure that there's a really true need for it. Number two is um, don't build a mesh just to build the mesh. Well, that's kind of like number one, but always have a consumer for the data. You don't need to have to shop your data product around. It kind of pointless. Like, I have some data. I don't want to shop. I don't think I need to have to shop my data around. Um, for a consumer, there should already be a consumer for your data, so that there's a way to at least charge it back, or at least attribute it to a specific use case that's in another domain, right? Because if you're providing a data product, it's going to cost your domain um, money and time, and that has to come from somewhere, and that has to be at least you need to be able to take credit for it at least, and there needs to be some way of actually uh, have that relationship between the two domains be um, secure and right, and balanced and fair. I think number three, if you're just getting started with the data mesh, is to um, don't you could create a data product without having to build the data pipeline, right? Create so your data product is just what your data product is. Is it an append or a change stream? Um, and the schemas that go along with it, some of that metadata, so that it's enough to for consumers to find in a data catalog, right? So they could go into a data catalog, look for a user's data product, for instance, see that it's there, but the infrastructure or the pipeline, it hasn't been built um, behind it yet. So then you would be able to find your first customer that way. They request, hey, I need this data product. And then you then have to negotiate that contract between yourself, the producing domain and the consuming domain. So those are the first three things at least I would think about, because there's a lot of people like to kind of omit the economics behind it, but there's always going to be time and effort taken away um, from the domain engineers. Your self-service tools should make it easier for them to not take too much time, but there is still time and resources that need to be used to provide it. So you want that relationship to be fair between producing and consuming. So economics part is hard. That's not something that I've really delved into into solving.
I have one final question for you. Given that you're working at StarTree, Apache Pinot behind it, how can people start using streaming databases more effectively?
Yeah, so Pinot is a real-time OLAP system. Basically, what it could do is read from Kafka, like real-time data, and also read from, say, a data warehouse, and marry the two together in analytical form. One thing a mistake I've seen many often is that users think the query or the results or the analytics that you get from something like a Pinot in real time is the data product. Like, like if I say what's the count of purchases in the last hour, um, that's the data product. I don't think that's a data product. I think that is a query on a data product. So for instance, you're going to get a feed of uh, of real time data purchases that's going to go into a database like a Pinot that and that data now in Pinot is your data product. The queries you apply on top of that data product are the analytical results or the answers to the questions that you're asking of that data product. So it's more important. It's more important to know where the delineation is, where analytics start and the data product begins, and that's where Campino really provides a way for you to get analytics from your real-time data products.
That's a good answer. Well, Hubert, I really appreciate it. Your book, obviously, Streaming Data Mesh, is out there. You have another book coming out pretty soon. I believe it's on streaming databases, so people can be on the lookout
Right.
for that. Thank you so much for being here. I really appreciate you sharing so openly. Thank you.
Thank you, Jesse. I really love your podcast, and I hope everybody's going to watch this. See you more. I think these are
Thank
great
you.
conversations.
Thank you.